Good morning. Today we discuss about the graphical simplification of Boolean expression, that is Karnaugh Map, in short K-map. In the previous class we discussed about the simplification of Boolean expression using some identities and laws. Today we go for simplification of Boolean expression or logic circuit using a graphical technique called as Karnaugh Map. Here we arrange the zeros and ones in the truth table into a graphical representation that is termed as Karnaugh map, and then we group those zeros and ones, and then we can simplify the expression. For a K-map simplification, we want to know the number of variables. Depending upon the number of variables, the number of we have n. If there is a n number of variables, we have 2 raised to n number of cells. A cell is a 1, that is a square that is represented in this graph. If n is 2, we have 4 cells. That means for a 2 variable system, we have 4 combinations, that is 0, 0, 0, 1, 1, 0 and 1, 1. Correspondingly, we have 4 cells. The first cell that is shown here, that where a is equal to 0 and b is equal to 0. So we can represent it as a bar, b bar. The first mean time a bar, b bar. Then second cell where a is equal to 0 and b is equal to 1. So we can represent it as a bar, b. And then third one, here a is equal to 1 and b is equal to 0. So we can represent it as a b bar. And the fourth one, here a is equal to 1 and b is equal to 1. So it is an ab. So in a row wise, here a bar, first row is a bar and second row is a. In a column wise, here b bar and second column is b. So we can group these we can map these 4 mean times into this graphical representation. Then corresponding indices are given by, here a is equal to 0 and b is equal to 0. So this cell is 0, 0. That is, here indices is 0. And then here a is equal to 0 and b is equal to 1. That is 0, 1. Here indices is 1. Then here a is equal to 1 and b is equal to 0. So indices is 2. Here a is equal to 1 and b is equal to 1. That means indices is 3. If a given function, if a function is given and its indices or positions are given, we can map those to this graph based on this indices value. Then we can also map the max times into this Karnaugh map. Here 0 is represented by a and column wise 0 is represented by b. So here row wise it is a, and in a second row it is a bar. In first column it is a, b, and second column b bar. Then for a 3 variable K-map, we have 2 raised to 3, that is 8 number of cells. We have 8 combinations that are mapped into each cells. So we have 8 cell and 8 combinations. The first combination is a bar, b bar, c bar, that is a is equal to 0, b is equal to 0 and c is equal to 0. Here in this row a is 0 and in the second row here a is equal to 1. Then we have 4 combinations 0, 0, 0, 1, 1, 0 and 1, 1. The first column, that is b is equal to 0 and c is equal to 0. So here b bar, c bar. Here b is equal to 0 and c is equal to 1. That means b bar c. Then listen here, the third column, that is b is equal to 1 and c is equal to 1. That is here bc, in this column bc. Why we go for like this? That means we want to group 2 adjacent cells. That is, we want to group this cell and the next cell. We want to group this cell and this the next cell. So we want to ensure that there is only one variable difference. We want to ensure that one variable difference. Just listen here. Just look here. Here the a bar, b bar, c, and next cell a bar, b, c. Here a bar and c are common. We can take common. So b bar plus b. So only the variable b is varied here. B is equal to 0 and b is equal to 1. Then here BC has a value B is equal 1 and C has a value 0. So here this is B C bar. So corresponding indices are 0, 1, 2 and then 3. Then here 4, 5, 6, then 7. Okay, next move on to a 4 variable CAM map. Here AB has a 4 combination and also CD has 4 combination. Here also after 0 1 1 1 will comes. Here also after 0 1 1 1 will comes. The corresponding indices are 0 1 2 3 4 5 6 7. Next 8 is in the last row. 8 9 10 11 12 13 14 and 15. Then we can group these values that is shown in the truth table. We map those values into the K map and group those values. We can do an example. Start with a OR gate truth table. We know that for an OR gate, when A is equal to 0, B is equal to 0, output Y is equal to 0. When 0 1, output is 1, 1 0 1 and 1 1, output is 1. We map these two table values into our graphical representation. There is a two variable graphical representation, two variable K map. Then we have 1 at 0 1. So we map to A is equal to 0, B is equal to 1. We map to 1. Then next A is equal to 1, B is equal to 0. We have 1. A is equal to 1, B is equal to 0. We have another 1. Then another one is A is equal to 1 and B is equal to 1. That is shown here. Then we can group the adjacent one. Here these two ones are adjacent to each other. So we can group those ones, and here B is equal to 1 in this row and in this column. Here A is equal to 0 and A is equal to 1. So the same variable and its complement. A variable A and its complement comes in the same group. So we can cancel that variable. So we can represent this group as B. Then next we can group these two ones. These two ones are also adjacent to each other. We can group these two ones. Then here A is equal to 1 and B is equal to 0 and B is equal to 1 here. So the variable B and its complement comes in the same group. So we can cancel the variable B, and this group is noted as A. So overall expression, this group plus this group. So A plus B. This is a SOP expression. That's why we represent first group name, that is A, plus the second group name, that is B. We move on to a three variable system. Here we map these two table into this graphical representation. Here A is equal to 0, B is equal to 0 and C is equal to 0. That is this point. We have a 1. Then next one is at 0 0 1. That is A is equal to 0, B is equal to 0 and C is equal to 1. Here we have next one. Then next one comes at 1 0 0. That is A is equal to 1, B is equal to 0, then and C is equal to 0. Here we have next one. Then next one 1 0 1. That is here. Then next one is 1 1 0 1 1 0. This is here. Then triple 1. That is at 0. So we can next group this one. These four ones are adjacent to each other. These two rows or these two columns are adjacent to each other because only one variable is different. Here just a lesson here. Here C is equal to 0 and here also C is equal to 0 and A is equal to 0. Here A is equal to 1 and B is equal to 0. Here B is equal to 0. Only the variable A is varying here. So these two cells are adjacent to each other. Similarly, these two also. Then in a row, in a column wise, these two are same. These two are. So we can map these four cells. Then and the corresponding representation is here 0 and 1. So the variable C is cancelled here. Here A is equal to 0 and A is equal to 1. So that is also cancelled. Only B is here. Then next we can map these two ones and corresponding. What will be the corresponding representation? Here A is equal to 1 and A is equal to 1. Here b is equal 1 and b is equal 0. So b variable b is cancelled, only a and then c bar is here. So the overall expression is b bar plus ac bar. Then move on to some example for your better revision. Go through this example and then you can do an exercise problem. Let the function f1 is equal to m0 plus m1 m2 plus m3 plus m4 plus m5 plus m6 plus m7. That means in this way meantime we have a 1 and others are zeros. So we can map these meantime into our k-map. It is a up to 7. That means we want to represent 7 combination. Here maximum is m is equal to 7. We want to represent 7 combination. That means it is a 3 variable system. We have mapped this to a 3 variable k-map, and similarly f2 also it is a 3 variable k-map. Okay, thank you.